Hello and welcome back to my tutorial on conditional trigonometric identities. So in this video we'll be looking at another question based on conditional trigonometry, and here we are given the condition as usual that sum of angles A, B and C is equal to pi radian, and by the help of the given condition and the left hand side we have to prove the expression on our right hand side, which is 2 plus 2 cos A dot cos B dot cos C. So at first we'll start with our given condition. So this is our given condition that A plus B plus C is equal to pi radian. Now what I'm going to do is I'm going to subtract C on both sides of this equation. So this results A plus B is equal to pi radian minus C. Now I'm going to operate this equation first by sign on both sides. So I have sine A plus B is equal to sine pi radian minus C. We know that sine pi radian minus C is equal to sine C. So we can simply say sine A plus B is equal to sine C. Similarly, if I operate both sides on cos, I get cos A plus B is equal to cos pi radian minus C, and cos pi radian minus C we know is equal to cos C, so we can derive the conclusion that sin A plus B is equal to sin C and cos A plus B is equal to minus cos C from our given condition. Now let me start by taking left hand side. So here is our left hand side, sin squared A plus sin squared B plus sin squared C. Now I'm going to multiply both. I'm going to multiply this expression by 2 divided by 2, and this doesn't make any change to our equation. Now I'm going to distribute the 2 on numerator to the expression inside the parentheses. So on multiplication I have 1 by 2 times 2 sine squared A plus 2 sine squared B plus 2 sine squared C. Now I'm going to change 2 sine squared A and 2 sine squared B in terms of cos, and we have the formula that cos 2A is equal to 1 minus 2 sine squared A. So from this formula what we can derive is 2 sine squared A is equal to 1 minus cos 2A. So we can simply write 1 minus cos 2A instead of 2 sine squared A. So let's do that. So instead of 2 sine squared A, I'm going to write 1 minus cos 2A, and instead of 2 sine squared B, I'm going to write 1 minus cos 2B, but for this 2 sine squared C, I'm leaving it alone. Furthermore, what I can do is I can add 1 and 1, so I have 2 here, and for this cos 2A and cos 2B, I'm going to take negative sign common, and then I have cos 2A plus cos 2B, and for this 2 sine squared C, I'm leaving it as it is. Now I'm going to apply the formula for this two expression. Say it is in the form cos C plus cos D, so we can apply the formula for cos C plus cos D, which we know is equal to cos C plus cos D is equal to 2 cos C plus D by 2 dot cos C minus D by 2. So on applying the same formula, here we have 2 cos C is 2A and D is equal to 2B divided by 2 dot cos C minus D is 2A minus 2B divided by 2, and then finally I have 2 sine squared C. Now for this term, what I can write is I can take 2 common, and then I have A plus B divided by 2, so simply I can write cos A plus B for this expression, and for this expression I can directly write cos A minus B. So let's do that in our next step. So this is what I've done in my next step. Now for this cos A plus B, what I can write is I can directly write minus cos C. So let's do that. So instead of cos A plus B, I can write minus cos C, but this minus multiplies with this negative sign and becomes positive, so that I can get rid of negative sign here, and the negative and the remaining term I'm going to write it as it is. Now we have here cos c, but here we have sine squared c, so let's change our sine squared c in terms of cos. So for this sine squared c, I can write 1 minus cos squared c according to our formula, and let me distribute this 2. So after distributing 2, we have 2 minus 2 cos squared c. Now I can add this 2 and this 2, so I have 4 here, and 2 cos c dot cos a minus b, and then finally I have minus 2 cos squared c. Now let me take 2 cos c common from these two expressions in my next step, so I have 1 by 2, 4 minus, now I'll take plus 2 cos c common, and then I have cos a minus b over here and minus cos c over here. Now once again I'm applying the formula for cos c minus cos d, so we have the formula for cos c minus cos d, which is 2 sine c plus d by 2 dot sine d minus c by 2. So let's apply the same formula here. 4 plus 2 cos c 2 dot, so for cos, this is our c, this is our d, so 2 sine c plus d by 2 dot sine d is d, sorry, our d is equal to c, so d minus c divided by 2. Now let's look for what we can do. So for this, I have here a plus c minus b by 2 after rearrangement, and we know from the given condition that a plus b plus c is equal to pi radian, so a plus c should definitely be equal to pi radian minus b. So here I can write pi radian minus b, and then I have another minus b divided by 2, so this gives pi radian minus 2b divided by 2. Now if I distribute this 2, I have pi radian by 2 minus 2b by 2, which is equal to b. So that for this expression I can directly write sine pi radian by 2 minus b. Now let's look for this expression, what we can do. Sine c, now if I distribute negative sign, I have minus a and then plus b divided by 2. Also we can write c plus b or b plus c, you can say it either way, is equal to pi radian minus a. From our given condition we can write b plus c is equal to pi radian minus a. So I write pi radian minus a here. I have another negative a and then divided by 2. So if I distribute this 2, I have pi radian by 2 minus 2a by 2. So I can simply write sine pi radian by 2 minus a here. Now let me replace this expression with this expression and this expression with this expression. So after that we can further simplify. We know that pi radian by 2 is equal to 90 degrees, so sine of 90 degree minus b we know is equal to cos b, so I can replace this sine pi radian divided by 2 minus b with cos b, and similarly for this expression I can replace with cos a. Once again let's look for what we can do. We have 4 here, 2 times 2 is simply 4, and then we have the product of cos a, cos b and cos c. Now I'll take 2 common from this 4 and this 4, and inside the parenthesis I have 2 plus 2 cos a dot cos b dot cos c. I can cancel this 2, so finally I have 2 plus 2 cos a dot cos b dot cos C, and this is our expression on right hand side right over here. So we have proved this question. It's pretty lengthy, but I hope you got the concept for how to solve this question, and thanks for watching.